Welcome to another video where we will be making a TooTallToby practice model. But this one is a special one because first of all, it's an assembly, and second of all, it's jam-packed with cool little tricks we can do in Alibre to get it done. So let's get started. Let's take a look at the drawing first, right? So this is a drawing. It's an assembly of a shelf, basically, right? And there are a few new things if you're used to TooTallToby's practice model. First of all, the system is MMGS. MMKGS because we need it in kilograms. The material, various materials, right? And the density also varies if the material vary. So we need to go here to check out the materials. The shelves are going to be made out of ABS. They are solid, as we can see. Okay, and the legs are going to be made out of 1060 alloy. Now, something I should have noted in my previous TooTallToby practice models is in Alibre, you can just use the 6061-T6 aluminum. It's got that same density. So in the standard materials Alibre gives you, there's no 1060 alloy, so you don't need to go make it, right? Just use the 6061 T6, it'll give you the same density. But look, there are some very interesting details. First of all, the legs have this 4-degree angle going up in this view, but from this view they're straight. Okay, so 4-degree angles on one side. So if you're looking at it this way, you have the 4-degree angle, and if you're looking at it this way, they're straight. Okay, and also they're hollow, right? It's a aluminum square tube, 30 by 30 millimeters and 5 millimeters wall thickness for the tube. Plus, final little detail, the feet, these tubes are flat on the bottom and flat on the top. Okay, so how are we going to do that? Well, first of all, I'm going to use a Thin-Extrude. How are you going to get that? Well, you could sweep it, right? You could do a sweep, but I'll show you how to do it with an extrude, right? Because that's a really cool trick in Alibre. And then we will draw these shelves with a top-down designing technique. So we'll insert the leg into an assembly, position it correctly, and then draw the shelves inside the assembly, because then we can use a cool little trick to make these indentations here, right? Which is also very cool, and I'll show you how to do that. So without further ado, let's start. I'm going to we will start with the legs, which I will make as a simple part. Okay, and I'll start with a center rectangle, 30 by 30. We need to give it a vertical or horizontal constraint somewhere to fully define it, and we're done. Okay, now I want to show you how to do that with the extrude method, which is very interesting. Let's remove that distance. Let's do 10 first, see where that. Okay, that's going the correct way. So I'm going to create a second plane at 1000 millimeters of height, right? So there you go. So that's a meter high. So, you know, right around below the waistline, or right around the waistline. That's what a meter is. So I'm going to create a plane at that distance so that I can end my extrusion there, and I'll show you why I'm doing it like that. Now, secondly, I'm just going to come in this XY plane. Sorry, ZX plane. Am I showing my planes? Yes, I am. Look, this is the plane I just made. Okay, it's going downwards, right? It's in the Z plus. So let me reset my view. Now the Z is going upwards. Okay. just gonna make a couple of lines here, make them equal. The reason I'm making them equal and giving them a dimension is I don't want these lines changing. It's just good practice, right? If I was speed modeling this, I wouldn't be doing this whole song and dance. I would just do what I need to do to get this 4-degree angle. So now I've got a reference line that has that 4-degree angle only on one plane, just like we talked about here for this leg. Okay, so what am I going to do? I'm going to, let's deselect it. I'm going to start the insert axis from sketch tool, select that reference line. It does take reference lines as input, no offset, apply, cool. Close that sketch. Now, I've got this little axis at 4 degrees of angle. And I have my profile. Okay, so now I'm going to start a thin extrude. Okay. This is going to be my sketch. I need 5 millimeters of thickness, right? As per the, well, this doesn't look like it's to scale, but yeah, okay. Okay, this doesn't look like it's to scale, but you know, that's what the print says. And to geometry, I'm going to select this plane I made, which is plane 1. Okay, cool. I've made this leg, but look, this is the axis I just made, okay? And this is going straight up. It's not following that axis. Well, we have a direction option in the extrude command in Alibre, so I will uncheck a direction along the normal, and and then it asks me to select the direction, and I can give it an axis or an edge. In this case, I have this axis, and look at that. Okay? We just made the leg. And that's it. Now, the reason I made this plane is this. Let me show you why. If I say that I don't want to extrude up to a particular geometry, and I just say that I want to extrude 1,000 millimeters, if we look at it on the side, it falls slightly short. Okay? Why is that? Well, that is because this is 1,000 millimeters, right? Got it? It extrudes a length of 1,000 millimeters, but given that this has a 4-degree angle, I'm only getting around, well, it's, I'm only getting the cosine of 4 degrees multiplied by these 1,000 millimeters of height out of this leg. Okay, and I don't want that. What I want is to go all the way to the 1,000 millimeters. So I'll just extrude up to that plane, and that's it basically, right? So we did the leg. That's it. It's a couple of sketches and one single feature, and that's it. And we're done. So now I'm going to save this, and I'm just gonna make a folder here, call it TooTallToby Assembly, right? And I'm going to save that shelf leg there. Okay, we're done with this. I'm going to close this and start an assembly file. And I'm going to call this TooTallToby Shelf Assembly. Okay, and I want to insert the shelf leg. Okay, let's just drop it in, right? Not going to say drop it like it's hot. It's a bad joke, and I'm not going to make it. So I'm just going to drop it in. And now we need to place it correctly. Now, we know that at the bottom, the feet need to be 360 millimeters apart. Okay. And at the sides, we need them to be 330 millimeters apart. So how do we do that? Well, first of all, we've got the reference geometry of the assembly showing. So I'll click somewhere on the model, hit Alt 0, and now I also have the reference geometry of the model showing. And as you can see, the bottom of this leg is centered on its own reference planes. So, side with the angle, 360 millimeters apart. Okay, so how do we do that? So we start our constraints and we will select this plane and this plane, but we don't want them coincident. We want them offset. Okay, now a positive offset would push it towards the left. I want it to go towards the right. By how much? Well, 360 divided by 2, right? That would put the plane at that location. Okay, but I want the outer edge to be at that location, so I need to shift it a little bit more. By how much? By half of the profile of that square tube, so 15 millimeters. Okay, and if we take a quick measurement here from this edge, from this edge, okay, it's selected, up to this plane, let's do that again. If we take a quick measurement from this edge up to that plane, 180 millimeters. So we did that correctly. Okay, let's do the same now for this side. Well, here we need this plane and this plane. That's what we need to constrain, right? And here we want 330 millimeters. So we will do the same thing. We don't really care about the side now, so this is going to be 330 divided by 2, and that will position the center plane. We want to shift it by 15 millimeters so that we position the edge. Let's take a quick measurement again and verify. 165 distance, that is correct. Well, yeah, I didn't want I didn't want to constrain it anyway. So here we are. Okay, now that leg is in position. Let me hide its reference geometry. So that leg is in position. Okay, so but we need 4 of them and we only have 1. So the way I do it is, right, 2 of them. This is the point. So I'm just going to create. Okay, so I'm just going to create the opposite of that leg with a circular pattern, and then I'm going to mirror the original one. Mirror plane. No, this is the mirror plane, and I'm going to mirror the original one and the patterned one, and we're good to go. Okay. So now we have the legs, and what's left to do is make the shelves. Okay, so I will make the shelves using a top-down modeling technique. So I will call these T shelf. Well, the name is kind of inconsequential. You will see why later. And I wanna draw them, right, on the plane that doesn't have the angle on the legs, right? I don't want to be drawing here. I want to be drawing here. Why? Well, because it's going to be easier for me. And we want 4 shelves, 4 arbitrary squares. Let's make these equal. Okay, because you will see that these shelves, they all have a height of 50 millimeters. Okay, so there you go, 50, 50, 50, and 50. Where they're different is their placement. So this is 150 millimeters from the floor, as it were. This is placed so there's 350 millimeters of space between the two shells. This has a spacing of 200 and this has a spacing of 100, right? And if you add that up with the 450s, you will get the 1000. That is the height. So let's go do that. Now we made them all equal. We also need to make these lines equal. So we'll give them their so we'll give them their length here as 50. Okay. And we will say that this side is collinear to that. That's and that side is collinear to that. Okay. And then we need to place the other ones. And you see that they're falling into place now. And all I have left is to give them the distance values. So I'll just say a 150 here. And that was 350, I think. And that was 200, I think. And now, if we did everything correctly, and I'll just do it like that to verify, if I make these 2 points coincident, I should be left with 100 millimeters. Yeah, there you go. Okay, so I'm just putting this as a reference, dimension in there, just to verify that I did everything correctly. And yeah. Okay. And how much will I extrude that? Well, I want to extrude that sketch. Cool. Okay. And I want to extrude it mid-plane. Okay. But by how much? Well, I want to make sure that my shells are bigger than all of the legs, right? They cross all of the legs. So if I give them this value here, right? If I give them this value here, because that's the distance at the bottom of the legs, I'll be sure to be sticking out from these legs. Which is what I want to do. So I'm just going to say mid-plane and 360. Okay. We are still designing inside the part while in an assembly. Okay. We've already referenced these legs for the width of the shelves. Now I'm going to reference them again. Make them geometry. Okay. And what I'm going to do is this. Okay. And make that collinear. Okay. So I made the profile. Now this is the cut I need to take. Okay. I have a warning. Overlapping features. Why do I have overlapping features? Let's analyze. Got an open loop. Sure. I don't want that. I got more problems. Degenerate feature. Heal. Now it's healed. If you have a problem, you get this, you analyze and you get this heal button and you click it and it fixes it by itself. So I'm not sure what the problem was. I just told Alibre to fix it and fix it by yourself. Anyway, so that's it. Now I'm going to mirror that cut along this plane. So where we're at? Well, we have our shelves, but we need to take these cuts, right? Okay. I just realized that if I had made these legs as solids, my life would have been easier. But again, okay, so this is the way I would have done it in a speed modeling competition. So we have the shelves. Okay, let's exit out of the top-down manufacturing designing method, right? So we've got our constraints here. We have inter-design relations going for the shelves. So how do we take these cuts on the corners? You see we're overlapping now. So how do we take these cuts? Well, we're in the assembly now, top level assembly, and we have a tool here called Assembly Boolean. So the part that is going to be affected is the shelves, okay? And the tools are the 4 legs, okay? So let me select these 4 legs. And insert results into current assembly. Yeah, do that. Okay, so what did it do? It created a new part called Assembly Boolean, okay? Now the initial one we can suppress, okay? And if we edit this new part in a separate window, let me regenerate it so we can look at it. It's cut. It's been cut, right? Now, a few things. When you use assembly boolean, the result is a dumb file. It's like a stamp import, right? You don't get a feature tree. So this is not parametric. Okay, keep that in mind. However, it's a hugely useful tool, okay? But we have these. Now, if I had made the legs solid, taking this assembly boolean cut and then shelled them, I wouldn't have these pieces to deal with. But now I do. So how do I deal with them? Remove model pieces, okay? And I just need to go click all of them. Alibre calls them lumps, funnily enough. It's a weird name for them, I would think, but yeah. I need to check these two as well. Okay, we have our shelves, and let's give them a material too. And as soon as I close this window and get back into the assembly, they have been updated, right? So I need to do that. I also need to assign a material to these legs because I didn't assign it before. Okay, let's hide everything. Now, I've got my shelf legs, I've got my assembly boolean, I have this which is suppressed, and I have materials assigned, okay? So now, if I calculate the mass, I should get the correct answer, which is, by the way, 22.9 kilograms. So I hit calculate, and if I go to a precision of 1 digit, 22.9 kilograms, almost bang on, right? So that's how I would do it. We saw how to extrude along a direction instead of the normal of the sketch plane. We saw assembly booleans. I think this is a great model. I really enjoyed it the first time I made it, and I think there are some interesting takeaways from it as well. So if you want more videos like this, hit the subscribe button or click on the video in the cards and watch the next one. And if you liked it, hit the like button. And if you disliked it, hit the dislike button because I still need to know. And I do hope I see you in the next one.